The 4.6-meter diameter, 82-kilometer long Lesotho Highlands Water Project tunnel is a vital link conveying water to South Africa from several catchments in the northeastern highlands of Lesotho. The first large dam of this project, built on the Malibomatu River, was the 180-meter high Katse Dam, to which the tunnel was connected. This was followed by the construction of the Mahali Dam at the same altitude on the adjacent Senkunyani River, which was connected to the Katse Dam by tunnel so that the water level of the two dams always remained the same. A third catchment, that of the Matoko River, was then added via a 6-kilometer long tunnel also into Katse Dam, and a fourth catchment of the upper Senku River, the Orange River when it enters South Africa, will be added once the third large dam, the 165-meter high Podihali Dam and 38-kilometer long tunnel to connect into Katse Dam, is completed in about 2029. The construction of the water tunnel to South Africa was divided into 3 sections, each under a separate contract, and were designated the transfer tunnel, 46 kilometers long, from Katse Dam to the Moela hydropower station. The second was the delivery tunnel south, 13 kilometers to the South African border, and the third section, the delivery tunnel north, from the border to the outfall, some 10 kilometers north of Clarens. 5 tunnel boring machines, TBMs, were used to excavate the tunnel, 4 in Lesotho and 1 in South Africa. The one used for the delivery tunnel north was a closed double telescopic cylinder, specially designed to work in soft collapsing rock, by constructing the precast concrete tunnel lining while simultaneously excavating the tunnel. The lining consisted of precast reinforced concrete segments, 250 millimeters thick, 1,400 millimeters wide, weighing 2.5 tons. This was built into rings of 5 segments, with a keystone segment to compress the ring. Altogether, 84,000 steam-cured segments were made in the factory on site. Despite having to line the tunnel as it advanced, this TBM kept up well with the other 4 machines, which were working in the hard basalt rock, but which were not designed to line the tunnel simultaneously, as they needed very strong side thrust to withstand the force on their cutters to penetrate the hard rock. On completion of the last phase in 2029, a total of 160 kilometers of tunnels will have been built. The tunnel was opened in September 1996 and has performed extremely well, producing a maximum flow rate of about 40 cubic meters per second, more than was expected, as a result of the high quality and smooth surface texture of the concrete lining. As the water flows towards South Africa, it passes through a hydropower station, generating 75 megawatts of power that Lesotho would otherwise have had to purchase from Eskom. Water being one of Lesotho's biggest export commodity and also vital to South Africa, the project is a great benefit to both countries and will be in operation for many generations to come.
My husband, Graham, and I were invited to go to the Ash Drive hole-through ceremony on the 12th of November 1993. The following notes are from my diary. Left at 9:30 this morning to pick up Anne and Don, parked at Larola and were taken by minibus to Ash River worksite. Enormous stand from which to view the breakthrough, flags, bunting and a good old-fashioned orchestra, all added to the festive atmosphere. Delay caused by power problem. Witty, interesting, off-the-cuff speeches by German and Swiss big bugs of contractors. Quite dramatic, as when power restored, the boring machine started up to bore through the last bit as the last bit of rock broke away, and then we could get a glimpse of the machine revolving and cutting through. Silence as it finally switched off, and we waited for the crew to climb through into daylight. A Sotho man with flag of Lesotho held high climbed out first, followed by a South African with our flag followed, and then one by one the rest of the crew followed. A moment in our history. The Ash River, the little stream that grew. When the Ash River was selected to convey the water from the Lesotho Highlands Water Project tunnel to the rivers leading to Katse Dam, it was a tiny stream, a little more than a metre wide at the planned position of the tunnel outlet. The planning engineers, a little arrogantly, decided to translate the name Ash River to Ash River before it was discovered that the word As means axle. The name given to the stream, where a wagon on the Great Trek had broken an axle crossing a rocky section. Nevertheless, the name Ash was retained. The first water gushing from the tunnel was allowed, as planned, to erode its way along the Ash River to the Katse Dam near Bethlehem. From there it flowed along the Liebenberg's Vlei and the Wilke rivers to the Katse Dam. This controlled process of erosion selected a section of a large prehistoric river that had once carried water from land high above Clarens and the surrounding area. Evidence of this ancient river was the discovery of smooth, scoured, solid rock riverbank, deep potholes, and dinosaur footprints on a large slab of sandstone adjacent to the river. Once the new river had carried out its task, steps were taken to minimize further erosion by building weirs at the steepest, fast-flowing sections of the river. The largest of these is the Katse Dam, about a kilometre downstream of the tunnel outlet, to prevent erosion in that section of the soft river bed. The continuous flow over the wide stepped spillway of this dam of cascading white water later gave its name Stortermelk, or spilled milk. The apparent amount of energy generated by the continuous flow, which varies between 25 to 35 cubic meters per second of water down steep sections of the river, prompted a young mechanical engineer named Anton-Louis Olivier in about 2006 to investigate the feasibility of generating hydroelectric power on the Ash River. He then obtained a large bank loan from Development Bank of South Africa and local shareholders and an agreement with Eskom for the purchase of his green power, as well as permission from the affected landowners and authorities. He formed New Planet and a special company, Bethlehem Hydro. 2 hydropower stations were then built, one onto the right flank of Katse Dam and one the farm Merino, about midway between Clarens and Bethlehem, commissioned in 2009 and 2010. Katse hydropower station, also the first commercial small hydropower station constructed in South Africa for 22 years. It was commissioned in November 2009 and is located close to Bethlehem, Free State. The power station has an installed capacity of 3 megawatts and has a double regulated frontal axis Kaplan turbine. The water flowing over the dam wall is diverted to the power plant to generate power and then return to the river. Number 2, the Merino hydropower is a run-of-river type hydropower station situated 10 kilometers downstream from the tunnel outlet of the Lesotho Highlands Water Project. The power station consists of an intake weir, a 600-meter canal, and a powerhouse with a regulated horizontal Kaplan turbine. The power station has an installed capacity of 4 megawatts. The contract for the Merino plant has a weir upstream in the power station to divert the water into the canal leading to the power station. The construction of the weir necessitated the construction of coffer dams to divert the river to facilitate construction of the weir. The river was diverted through a completed section of the canal and the inlet works during the construction of weir across the river bed. Thereafter, the river was diverted over the completed weir and the construction of the canal completed. He then, embarking on his own schemes, 2 power stations earned him enough money to build his flagship power station, which he called Stortemelk, as he had obtained permission to build it into the left flank of Bottelkloof Dam to make use of the energy, otherwise being dissipated over the spillway. This 5-megawatt power station makes use of a beautiful state-of-the-art German vertical turbine and a Spanish generator and ultra-modern control system, enabling it to be operated remotely. It was commissioned in 2018. The successful production of power on the Ash River prompted an overseas group to establish 2 more power stations on a less steep section of the river. These use the kinetic energy of the flowing river to generate 2 megawatts and 2.5 megawatts respectively, and were built on the farm Kruisfontein, Lower and Middle Kruisfontein power stations. Kruisvallei hydro plants were owned, built and operated by Red Rocket. Red Rocket commissions its Kruisvallei hydro power plant on the 9th of March 2021. A 6th power station on the farm just upstream from Kruisfontein, called Boston, is now under construction after negotiation with the respective landowners. The Boston plant is being built under the ownership of Serengeti Energy, a new company created and owned by REH, specializing in hydropower in Africa. The other 3 REH-owned power plants now also fall under Serengeti Energy, of which Anton Louis Olivier is the CEO. This 4.4 power station will be a miniature of the typical giant power plants with diversion weir, approach channel, head pond, penstock and turbine, and will have a height difference between head pond and tailwater of over 14 meters. It will be commissioned in 2026 and signify the completion of power generation installation on the now big Ash River. Falling about 100 meters from the tunnel outlet to its confluence, about 18 kilometers downstream from the Liebenberg-Vlei River, the Ash River will have provided the energy for 6 mini hydroelectric power plants to produce a total of 18.9 megawatts of green electricity, when the last of the 6 power stations presently under construction are completed next year. The Senku Bridge is indeed an impressive project. It's part of the second phase of the Lesotho Highlands Water Project and is said to be the largest extradosed bridge in Lesotho. The bridge will span the Polyhali Reservoir, stretching over 825 meters and standing 90 meters high. It's designed to withstand the harsh winter conditions of the Lekotlo Highlands and is expected to be completed by early 2026. The Senku Bridge is one of the 3 bridges being built along the Maseru to Lekotlo A1 road to the Mabanyane, Kubelu and Senku rivers to ensure access across the reservoir and connectivity to the national road network. This will enable access to Lekotlo town across the reservoir even at full supply and retain connectivity to the national road network along the A1, the main road between Lekotlo district in the mountainous northeast of the country and Maseru, Lesotho's capital city. This bridge will not only improve infrastructure, but will also boost tourism and economic growth in the region.
You too?
It's okay. Oh, start. I'm going to be 18 when we start.
Maar zou je waarschijnlijk zoals meer tijd gaat, zoals afgegaan met de
Dit zou cool geweest.
Ja, ik denk dat zelfs meer tijd gaat. De tijd met plannen is goed.
Cannot break through the tunnel until we finish the installation of the intake, because there's a sequencing procedure we need to follow. So we have to try and finish the excavation of the intake at more or less at the same time with the excavation of the tunnel. So when you break through the tunnel, you're not sitting there with the intake and you're breaking into nowhere. So there's a sequencing thing. So that's about it for now. The spillway is on top here. There's nothing much to discuss. It's still